Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 150. Please turn to it, page 150, and today is our lesson number 270. The very first problem that we see on page number 150 is the exact same problem. As a matter of fact, both of these problems are the exact same problem that appeared in the first edition of the book on the same exact page number. I have already done those problems. We did these problems on day number 37 and 38. This particular problem that we are about to solve is something that we did on day number 37. So if you need to look at the solution to this problem in a little bit more detail at a little bit more slower pace, you can go and watch day number 37. You will find the exact same problem. Okay, here we go. We are told here that A does the job in 30 minutes. We are told that person B does the same job in 48 minutes. Now we understand that when I say person A and person B, what we mean by person A is, here for us, person A is what they're calling machine R, and similarly what we are calling person B is our machine S. It doesn't change anything. Similarly, when we say job, when we talk about job here refers to, job is to make a given number, in this case x number of units. So according to the problem that is studied in the book, it says machine R does this x number of units in 30 minutes, machine S does the same number of units, x number of units in 48 minutes. You can read it like this, or as I said, A does the job in 30 minutes, B does the job in 48 minutes. Job is making the x units. What we are being asked to compare is this. Here's our column A. What we are being asked is how many jobs, it says how many jobs will A do in 3 hours. How many jobs will A do in 3 hours? How many jobs will A do in 3 hours? Which is a very straightforward question because we are told that A does the job in 30 minutes. So we know that A does 2 jobs in 1 hour. And if it does 2 jobs in 1 hour, that implies that A should be able to do, A will do 6 jobs. That was a very straightforward thing because it only takes him half an hour to do the job. In 1 hour it will do 2 jobs. In 3 hours it will do 6 jobs. That was the easy part. Let's look at part B, column B. Again, the question again is how many jobs will B do in 4 hours? How many jobs will B do in 4 hours? Now listen very carefully. There are 2 ways we can go about solving this question, answering this question. One is, there's 2 ways we can use to answer this question, to arrive at the answer to this question. One is what I call the classical way, the traditional way, the orthodox way, the geeky way, the nerdy way, the academic way, the mathematical way. And the other one is what we call the quick and dirty way. Quick and dirty way would be this part. This quick and dirty way is that we have to realize that we have 4 hours. 1, 2, 3, and 4. And each of these 4 hours, listen very carefully, each of these 4 hours is made up of 48 and 12. 48 minutes and 12 minutes. 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 Of course, these are hours. These are hours. 1 hour, 1 hour, 1 hour. Each of these 4 hours is made up of 48 minutes and 12 minutes because there are 60 minutes in an hour. Now we know that he does a job, we know that he does one job in 48 minutes. So that's one job, there's another job, there's another job, there's another job, there's 4 jobs right there. In addition to that, we have 12 minutes left over here, 12 minutes left over here, 12 minutes left over here, and 12 minutes left over here. We have a total of another 48 minutes. But that's one more job. That's one more job. That equals one more job. That's it, we're done. So how many jobs will this guy do in 4 hours? The answer is 5. He will do one job here, one. He will do another job in this 48 minutes. He will do another job in the third 48 minutes. He will do a 4th job in the 4th 48 minutes. And then out of each of the hours, we have 12 minutes left aside. We have 12 minutes put aside. When we add up all of those 12 minutes here, 1, 2, 3, and 4, when we add up all of those 12 minutes, we get another 48 minutes and we'll do one more job. So he was going to do 5 jobs. He will do 5 jobs. This guy is doing 6 jobs, so the answer is B. That's one way of figuring it out, the answer to this question here. The question was, how many jobs will he do in 4 hours if it takes him 48 hours, or 48 minutes rather, to do one job? Now here's the conventional way. Here's the conventional way, the classical way. The classical way, of course, is so called because it's very academic, it's very mathematical. There is no creativity here. You just set it up as a ratio problem and you solve it. So here's our job and here's our hours. We know that he can do one job in 48 minutes, and 48 minutes is simply 40 over 60 hours, because there are 60 minutes in an hour. Obviously, I don't know why I have to explain the bloody obvious. I can't help it. So if we divide top and bottom by 12, we get 4/5. In other words, 48 minutes is 4/5 of an hour. So he does one job in 4/5 of an hour. The question is, how many jobs will he do in 4 hours? Set it up as a ratio of job and hours. That's it. And just solve for x. Job and hour. Solve for x. So the x equals 4 divided by 4/5, and the 4 is going to drop out, and x equals 5. Just like we found before, x equals 5. Let's move on then to the next problem that you see on the bottom of the page there, on the same page number 150. That's it, we're done with this one. So in column B, we find out that person B is going to do 5 jobs in 4 hours. Person A, we found out, does 6 jobs in 3 hours, because it takes him only half an hour to do the job. Therefore, the answer is A. In second question that we see there, problem number 2, again, if you wish to watch the solution to problem number 2 in a little bit more detail, at a little bit more slower pace, you can go and watch the original video, which was day number 38. So here's what is given to us. Here is our list X, and here is our list Y, and here is the observation, and here is the frequency. So we have 1, 2, 3, and 5. We are told that we have 10 ones. We are told that we have 20 twos. We are told that we have 18 threes. And we are told that we have 12 fives. Similarly, for the list Y, here is our observation. And here is our frequency. 6, 7, 8, and 9. We are told that we have 24 sixes, 24 sixes, we have 17 sevens, we have 10 eights, and 9 nines. As you can see, each of these lists has 60 numbers exactly. Question is, and we are also told that the average, of list X is 2.7. The average of the 60 numbers in list X is 2.7. We are also told that the average of the 60 numbers in list Y is 7.1. And the question is very straightforward. We're going to put them together. We're going to call that list Z. So the Z will contain 120 numbers. Z we're going to make a list Z, which is simply, we're going to compile them together. Z is made up of 120 numbers put together. And here's the question. Column A and column B. Average of numbers in list Z versus median of list Z. Which one is bigger, average or the median? Now, first thing first, how do we figure out the average of these 120 numbers? Well, it's very straightforward. Listen, here we are told that the average is 2.7. If we are told that we have three numbers whose average is 2.7, listen carefully. If we are told that if we have three numbers and whose list is 2.7, then the sum of those three numbers must be 3 times 2.7. If we had been told that we have six numbers whose average is 2.7, then the sum of those six numbers would have to be 6 times 2.7. If we are told that we have 60 numbers whose average is 2.7, then the sum of those 60 numbers must be 60 times their average, 60 times 2.7. Similarly, the sum of these 60 numbers is 7.1 times 60. So this quantity represents the sum of all the 20 numbers. Sum of all 120 numbers. I meant to say sum of all 120 numbers, not 20 numbers. And if we were to divide this sum by 120, we'll get the overall average, which is what the first column is. Again, I'm not going to explain all the baby steps, I'm just going to keep on going. So if we take out the 60 common, 60 is the common factor here, here and here. If we take it out common, we end up 60 times 2.7 plus 7.1 over 120. And if we divide top and bottom by 60, we end up with 2.7 plus 7.1 over 2. What do we learn out of this exercise? What do we learn out of this exercise? What does this represent? 2.7 plus 7.1, right here 2.7 plus 7.1. We just added up these two averages, and we divided the sum of these two averages by 2. What we learned from here is that we didn't have to do any of this thing. What we have to realize is that as long as we have the same number of numbers in the two lists, this list has 60 numbers, this list has 60 numbers, as long as we have the same number of numbers in the two lists, then the overall average of the list put together, 120 numbers, is simply the average of the two averages. One more time, what we find from here is that as long as the number of numbers in the two lists is the same, then the overall average of the list that is put together by putting the two numbers from the two lists together, the overall average is simply the average of the two averages. You see, you add them up and divide by 2 because there are two of them and divide by 2. Let's write it down, shall we? I'm going to erase all of this thing because we need the room. Sum of all 120 numbers is simply 60 times 2.7 plus 60 times 7.1 divided by 120. Take out the 60 commons. 60 divided by 120, you get 2 down bottom, and that's what we get there. So let's make a note of what we just learned. Overall average of all 120 numbers is simply the average of the two averages. Average of the two averages. Provided what? There is a caveat. There is a caveat. There is a condition. Provided that the number of numbers has to be the same in the two lists. Now, if it turns out that the number of numbers in the two lists is not the same, let's say one list has 10 numbers, the other one has 20 numbers, then it doesn't change anything. It simply means that now we have to take the weighted average. If one list has twice as many numbers as the first list, then you have to take the weighted average, which is essentially what this is. We're taking the weighted average. This also is a weighted average, except here both of them have the same weights, the weight of one assigned to both of them. That's all. So it's still a weighted average, but it's just a weight of one. And that's all there is. So the average, overall average of the two numbers is simply the average of the two averages. Now we learned the word caveat long time ago, which means to put conditions on something, to restrict something. It's a caveat actually is a warning, it's a caution. So there is a caution, there is a warning here that the two numbers, the number of numbers in the two lists has to be equal. That's your warning, that's your requirement. That's your as I said, caution. When did we learn this word caveat? I want to learn it properly one more time in the vocab words. That's where we learn it. That's where we learn the words properly. And I would like to do that one more time. And I'm trying to find out which day we learned it. I know we learned the word caveat long time ago. Just give me 1 second. I'm looking at the list of C's. And if I don't find it, I'm going to look pretty silly here because I'm fairly certain. You see, I went from being I'm sure to fairly certain because I'm having trouble here. Perhaps we didn't learn it. I find it hard to believe that we haven't covered the word caveat in our vocabulary list. Oh, we did. Day number 63. What do you know? Day 63. Anyway, enough of the talk. So we are done with this part. So again, we need the room. So we need to erase all of this thing. So the average, the overall average right here, the average of the two numbers is simply this quantity right here. 2.7 plus 7.1 divided by 2, which is same as 2 plus 7 is 9, so it's 9.8 divided by 2, 9.8 divided by 2, I don't know what it is, but whatever the hell it is something less than 5. It's something less than 5. So that's the first column. Let's pick up speed. I've been going too slowly here. I've been going at a too much of a leisurely pace. Let's pick up the speed here. Now we have to figure out the median. How do we figure out medians of numbers? Well, median is the middle number after the numbers have been arranged in order. After all the numbers have been arranged in order, you just take the middle number. Here, the problem is, here we have 120 numbers. Here we have 120 numbers. Therefore, the median is simply going to be the average of the 60th number and the 61st number. The average of the 60th number and the 61st number. For example, if we only had 6 numbers, 1, 2, 3, 4, 5 and 6, the median of this 6 number is simply the average of the 3 and the 4, which is 3.5. So here we have to locate the 60th number and the 61st number, which is very simple, very straightforward. The 60th number is the very last number that is going to appear in the first list. And the first list we have 12 5s. Since there are 12 5, that's exactly what we have. We have 12 5 listed in a row there at the end. So the 60th number is 5. Similarly, the 61st number is going to be the very first number that appears in the second list. And the very first number that appears in the second list is 6. And we have 24 of those blasted things. So the 61st number rather is 6. And therefore the median is, the average of the two numbers, which is simply 5.5. And of course 5.5, we found out that the average was 9.8 divided by 2, which was less than 5, and therefore 5.5 is going to be greater than something that is less than 5. The answer is B. That's all. We're done. Enough of that. I will see you tomorrow, or we'll do the problems that you see obviously on the next page. Alright, bye now.